Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Stereoisomers arise from stereocenters, chiral centers. For a molecule with n stereocenters, the maximum number of stereoisomers is 2n, but this can be reduced if mesoforms exist. Moving on to the next step. Identify the structure of 2,4-dichloroheptane. The compound is CH3, CHCl, CH2, CHCl, CH2, CH2, CH3, heptane chain with Cl at C2 and C4. Moving on to the next step. Identify stereocenters. C2 bears H, Cl, CH3, and CH, Cl, CH to CH to CH to CH3, 4 different groups chiral center. C4 bears H, Cl, CH to CHCl CH3, and CH to CH to CH3, 4 different groups chiral center. And for the final step, check for meso possibility. A mesoform requires the two halves of the molecule to be mirror images of each other. At C2 the groups are CH3 and the C3, C7 chain. At C4 the groups are the C3, C1 chain and the C5, C7 chain. The substituents on either side of the C2, C4 pair are CH3, C1 side of C2 versus N-propyl, C5, C7 side of C4, which are not identical. Therefore, the molecule is not symmetric and no mesoform exists. Count stereoisomers. With 2 independent stereocenters and no mesoform, the total number of stereoisomers is equal to 2 is equal to 4. These are 2R, 4R, 2S, 4S, 2R, 4S, and 2S, 4R, 2 pairs of enantiomers, no meso compound to reduce the count. Why other options fail? A. 0, incorrect, there are 2 genuine stereocenters. B. 2, incorrect, this would apply if there were only one stereocenter. C. 3, incorrect, 3 stereoisomers would result from 2 stereocenters where one combination gives a mesoform, but no mesoform exists here. D. 4, correct, 2 is equal to 4 stereoisomers with no mesoreduction. Therefore, the correct answer is D. Therefore, the correct answer is option D.